You are watching the Factoring Trinomials Day 1 Notes video. In this video, we are going to learn how to factor trinomials using the box method that you are already familiar with when we double distribute. We should know our perfect squares because that will actually help us with some problems. And we are also going to learn how to factor the difference of squares. We can use the box method, but some of you might be able to generalize this because you're fancy. Okay, number one, review how to multiply binomials. We know how to do this. If you see something like x plus 4 all times x minus 2, we just use the box. And our final answer would be x squared plus 2x minus 8. But what if I gave you x squared plus 2x minus 8, and I want you to go the opposite way to find this? Would you be able to do that? All right, let's think about some things here. So the graph of x squared is equal to x squared plus 2x minus 8. This is the same problem that we just did above. It's just graphed over here. And if we can use our vocabulary word of the roots, what are the roots? Well, those are these 2 points here. So the roots are at x is equal to -4 and x is equal to +2. This is so weird. Those numbers look familiar, but not identical to above and number 1. Okay, let's just kind of go through factoring this trinomial. So when I look at this box method above, okay, didn't I see here, let me use the purple highlighter. The x squared term is usually always in this top corner, right? So let's just put it up there. X squared we'll put in there. Oh, we're starting with the inside and not the outside. This is weird. Okay, cool. And then that plus 2x, well, isn't that usually up top here in this corner? So I'm just going to write that there. And then this constant here of -8, that always falls down here in this bottom corner, okay? So this, my friends, is how we are going to set up factoring questions, because now what we're going to try to do is work backwards. What times what gives us x squared? If you said x times x, you are correct. Okay, now here's the tricky part. This is kind of like a little puzzle. Are you ready to have some fun? We need two numbers that multiply to 8. So some of you might say 8 and 1, others of you might say 4 and 2. The trick is it has to multiply to -8, but they have to add to +2x. So I'm going to try 4 and 2. So if I put 2x here and 4x there, the only way that I'm going to be able to get this to work, because right now it's not working, 4 times 2 is a +8. I need one of them to be negative. If you're thinking I need to make this one negative to make this true, you are absolutely correct. So my answers, you know how we used to have our answers from the middle of the box? Our answers come from the outside. X plus 4 all times x minus 2. And we could actually write this as x minus 2 all times x plus 4, because it doesn't matter what order you multiply in, because if we generalize it, 3 times 2 is the same as 2 times 3. So either one of these is the correct answer. Okay, so let's do some factoring. We are going to use a box method. I'm just going to set up number 3. Remember, the x squared goes here, the +22 goes down there, and that middle term of +13x goes in the top corner. So what times what is x squared? X times x. What two numbers multiply to 22? Well, that's what, 22 and 1, or 22 and 1, or 11 and 2. Well, we got to get to 13 somehow. So I'm going to try 11 and 2. And wait a minute, 2x and 11x. I think we found it. These are both positive. That's 13x. So my answer, remember, they come from the sides. So x plus 2 all times x plus 11. All right, moving on to the next one. X squared minus 14x plus 49. You got it. We're going to put all these in the boxes. So x squared plus 49 minus 14x. And then let's work backwards. X times x is x squared. What are two numbers that multiply to 49? The only ones that I can think of are 1 and 49 and 7 and 7. But somehow they have to add to this negative here. But they multiply to a positive? Oh, both of the signs have to be negative. So negative 7x grouped with a negative 7x is negative 14x. That's a check mark. It kind of looks like a V. So my final answer is x minus 7. Remember, we're taking it from the outsides. All times x minus 7. Okay, now this last one, you might panic a little bit because you might say, oh, the x squared goes here. But then there's nothing here. So I think that might just be 0x. So they have to add to nothing? Okay. Minus 144. Wait, how do you get numbers to add to 0? 5 minus 5, 10, negative 10, 20, negative 20. It's the same number, opposite signs. So is the number 144, is any number times itself 144? Yes, it is. It's 12. So 12 times 12 will give us 144, and x times x gave us that x squared. That was the easy part. But how do we get those to add to 0? Because right now, 12x plus 12x is 24x, and that's not a negative. 12 times 12 is a positive. If you think that one of them should be negative, you're correct. So this is what we call the difference of perfect squares. And I'm just going to show you a few other ones that you might see. So like 144 is a perfect square because 12 times 12 is a perfect square. You might also see something written like x squared minus, I don't know why this keeps doing that. You might see it written as x squared minus 9 because 3 times 3 is 9, or x squared minus 25 because 5 times 5 is 25. You might also see it as x squared minus 49 because 7 times 7 is 49. So whenever you see something like this, some of you might just be able to generalize it because what we just saw, this would become x plus 5 all times x minus 5. And then you save yourself the trouble of using the box. But some of you might say, no, the box is something that I'm comfortable with, and you can use it for every single one of these factoring questions.